So today we're going to talk about sampling distributions, which is another way of talking about continuous probability distributions. And eventually we'll talk about the central limit theorem. Okay, so last time we talked about probability distributions. We talked about theoretical probability distributions. So if you recall, we talked about situations such as flipping coins, where we could think about all the possible outcomes and all the probabilities associated with those outcomes. So that's one way that you can think about probability. And what we saw was that it wasn't so bad, right? There was some work involved, but it wasn't terrible. So as part of your homework, I asked you to talk about the probability distribution of flipping 3 coins. And we found out that there were 8 possible outcomes. And based on those outcomes, we were also able to identify the number of heads and the probabilities associated with those numbers of heads. So we knew the probability of 0 heads, 1 head, 2 head, and 3 heads. So by flipping 3 coins, we found that there were 8 possible outcomes. And it was a little bit of work to find that, but it wasn't a ton of work. However, if we had moved into the situation of flipping more coins, then we would see that the amount of work needed to come up with the probability distribution would be that much greater. So if we flipped 4 coins instead of 3 coins, there would be 16 possible outcomes instead of 8 possible outcomes. Or if we had decided to flip 5 coins, there'd be 32 different possible outcomes, as opposed to 16 or 8. 6 coins would ratchet things up to 64 different outcomes. So on the one hand, we recognize that listing all of these outcomes would not be impossible. But we also recognize that the more outcomes we have to list makes it that much more challenging. So what we did last time is one way to create a probability distribution. Today we're going to talk about an alternative form of discovering the probability distribution for some kind of activity or experiment. So what we're going to be doing is we're going to be looking at something known as a sampling distribution. So a sampling distribution is in fact a kind of probability distribution. However, the way we go about creating it is different than the theoretical probability distribution that we talked about last time. However, the characteristics of a sampling distribution are largely the same as those of a probability distribution. So your sampling distribution is going to, 1, show you all the possible outcomes, and 2, all the different probabilities associated with those outcomes. So the big difference here, though, is that this probability distribution, the sampling distribution, is created over the long run. So you're going to hear me use this phrase, over the long run, repeatedly today. So when you think about the statistics that we do later on in this course, all of those techniques, why they work, why they let us do inference, are based on this long run understanding of outcomes and probability. So I think the best way to talk about the sampling distribution is through an example. So last time we talked about flipping a coin. And we acted like we knew things about coins, that we were experts about coins. We knew how many sides a coin had, and through just thinking logically about it, we were able to determine the probability of the different outcomes that occur when you flip a coin. So if you flip a coin, you get tails. That means that there were no heads observed. If you flip a coin and it lands on heads, then this tells you that there was one heads observed. These are the only two outcomes, so we could conclude that your probability of seeing either of these two outcomes, that each one had a 50-50 shot of turning up. So that's one way to think about probability. Another way to think about probability is to try flipping some coins and to pay attention to what happens. This is kind of what we get at when we talk about the sampling notion of probability. So for a moment, pretend that you know nothing about coins. You've never heard of coins, that you don't even know what they look like. You don't know what happens when you quote unquote flip a coin. You don't know the kind of outcomes that could occur, and that you have no idea what the probabilities are of any of those outcomes. So you've got this object, which we're calling a coin, that we know nothing about. So one way that we can determine the probability distribution for flipping this coin is to do something that is actually fairly intuitive, which would be to flip a lot of coins. So the idea here being that if we took a coin, whatever that is, and we flipped it a lot, and we observed what happened, then we should be able to see all of the different outcomes, and we should get a sense of how likely each outcome is to occur. So here we're going to go to this website called Virtual Coin Toss. The only purpose of this website is to simulate the act of flipping a single coin. So this website is simulating the act of flipping coins. Every time I push the flip button, we get another result. So here we've got 9 heads, 9 tails, 10 tails. So we see that it kind of goes back and forth. But sometimes we have these streaks where one side occurs more frequently than another. So if we were to try to know about coins, if we were to say create the probability distribution for flipping a coin based off of actually flipping the coins, we would see, one, that there are 2 outcomes. The first outcome is heads, and the second outcome is tails. Looking at the results that we obtained, we would see that there were 11 heads and 16 tails. So according to this exercise, the probability of seeing tails appears to be a little higher than the probability of seeing heads. So here we've just flipped this coin 27 times. And we can keep on flipping it. And we can see now we're getting a few more heads, a few more tails, and so forth. So the information down at the bottom, where it says all time, this is a record of all the times that this flip button has been pressed. And it records all the results of those flips. Now, if we look at these numbers, we see that 1, this coin has been flipped a lot, and 2, that the number of times that it's landed on heads is fairly similar to the number of times that it's landed on tails. So there are 21 million and then some heads, and there are 21 million and then some tails. So we see that by continuing to flip this coin, that if we were to, say, flip this coin forever, we might get the sense that the number of heads and the number of tails that we see will be roughly equal. Okay. So think about it. We have one strategy for developing probability distributions. This strategy involves identifying all the possible outcomes and then thinking really hard about the probabilities of seeing those outcomes. This other strategy involves less thinking. This strategy involves taking a coin, flipping it a lot, and then just counting how many heads you got and how many tails you got. Right? It's much simpler to flip coins and count how many heads you observed than it is to make sure that you've identified all the possible outcomes there are. However, in the long run, the results are the same. In the long run, that probability distribution you created by thinking really hard will be the same probability distribution you get for flipping a coin a lot of times.